In this video, we're going to learn about coroutines and how they can be used to kind of give you a more free structure to your game design in Unity. Specifically, you can write methods that act almost autonomously, similar to threads, and you're able to write code in a more traditional kind of fashion. As opposed to being limited to code that executes in the update routine. So here I have a scene with a floor and a couple of spheres in it. And what I've done is I've set it up so that we have this script on the camera controller that will move towards the first sphere and then wait a second, and then turn to the right. So let's take a look at how that runs. So it moves, then it waits a second, and then turns to the right. And now let's look at how that's actually implemented using coroutines. So here's the script that implements the movement of the camera through the scene. So on the first line or the 10th line in the start routine, we see this start coroutine call. And what that does is starts a coroutine called move to target and passes the parameter target1 to that routine. And then if we go on, so that's basically telling Unity that we want to start this coroutine, and now it should manage that coroutine. Okay, so it's going to actually associate this coroutine with this script called camera controller, and it's going to start to make calls to that coroutine and manage how that coroutine runs over its lifetime. So Unity goes ahead and launches this coroutine, and it gets that target1 as its target. And in the beginning of this coroutine, we set a transition time of 2 seconds, so that's going to be the total time that the transition should take. And then we store the start time, which is time.time. That's the current time, right? And then we store the start position, which is the current transform.position. Then we go and we start a loop, and this loop starts off with a while statement, and we say while, and then we call this static method called distance as part of the vector3 class. So it's going to calculate the distance between the current position, transform.position, and the target position, right? And whatever that distance is, if it's greater than 0.01, then we're going to continue looping. So we're going to loop until we arrive at our target. And the reason we use a small value like 0.01, which is referred to as a delta value, is so that if we undershoot or we don't want to undershoot or overshoot it. So if we're moving by a discrete amount, then we might overshoot it if we try and get exactly on the target. So we're going to try and just get close, within some delta. So we're going to be looping until we get there, and then the line that we have within the loop is we're setting the transform.position to a new value, and this new value is going to be based on the current time where we should be along the path. So we do a linear interpolation, vector3.lerp. And the interpolation is between the start position where we started and the target position where we're going, and then where we should be as a percentage between 0 and 1 along that path. So we do that by getting the lapsed time, which is time.time minus the start time, and we put that over the total transition time. So if the transition time's 2 seconds and we're 2 seconds along, then we're 1 or all the way there, right? So we're all the way at transform or target.position. If we're to the contrary, if we're at 0 elapsed seconds in, then we're at we should be 0. We should be all the way at start position. So that would pass 0 out of 2, right? And if we're 1 second in out of 2, then we should be halfway, right? So that would be 0.5 or 0.5 between start position and the target position. And so that's going to set our position all based on time every frame that we run this, right? Then we have the next line, which is yielding until the next frame. So yield return null. So this is going to return the control to Unity. It's going to return from this method, but it's going to store all our method state. So all the state of this coroutine, like these variables up here, the transition time, the start time, and the start position, are all going to be preserved. And then when Unity calls this coroutine or calls back into it the next frame, it's going to resume right after this yield return null statement. So that's going to be the top of the loop, and then it's going to go through and check this condition again. And if we're not there yet, then we're going to run this position change again based on the new time.time, and continue on, and we're going to yield again, and then we're going to come back again, and we're going to continue on until we arrive at the destination or at the target. So after this loop kicks out, that means we've arrived at our target, and then we run this line here on 29 that says yield return new wait for seconds and 1. So wait for seconds is a type of object that Unity understands that when it's returned from a coroutine, that means that it should wait that many seconds. So it's going to Unity knows not to call back into this coroutine now until 1 second has elapsed. And so this yield statement will return control to Unity, and then Unity will call back in once this time has passed. And then what we've done is, now if we didn't have any more statements, the coroutine would end, right? And that would it would be all done, and we will have moved to our destination. But since we also want to rotate or look to the right, we start another coroutine right before we exit this move to target coroutine, and that coroutine is rotate right. So we start that coroutine, and then we return from this coroutine, or this coroutine ends, right? The next line. So this coroutine move to target is done. And now we've given Unity a new coroutine to manage, which is rotate right. So, and rotate right works similarly to the move to target coroutine. And we set a transition time, again, of 2 seconds. We set the start time, which is equal to the current time. We get a starting rotation, which is transformed out rotation. We get a target rotation, which is the static method of the quaternion class called look rotation, right? And we set it to look along the direction vector 3.right. So it's going to look along the vector, the direction of right, okay? So now that we have all this information stored, we can easily loop through and say, while quaternion.angle, which is the difference. So any difference between rotations would be an angle, right? Just like the difference between vectors would be a distance, the difference between rotations would be an angle. So we have the angle between the current rotation as of this frame and the target rotation. While that's greater than 0, keep on looping. So while I haven't reached the angle I want, I'm going to set my rotation equal to the quaternion.slurp, which is a spherical interpretation. There's also a quaternion.lerp. They're just slightly different. Spherical rotation or interpolation is often used for quaternions, for rotations. So we're going to interpolate between the starting rotation that we recorded. The target rotation is going to be the destination, and we're going to use the same formula, the elapsed time over the total transition time. And then we yield return null, and so then we come back, check that condition again, and keep on running in this loop until we arrive at our final destination. So let's look at that one more time, how that looks. Go there, wait 1 second, turn, and then we're done. So that's pretty good. So now let's look at if we wanted to maybe move to the second target as well. So we'll go back to our code, and you might think that I might be able to just start coroutine at the bottom of the rotate right method and start the move coroutine again. So start coroutine, move to target, and then maybe like target 2, right? And of course, I do need a second target, right? So that's correct. So I'll add a target 2. But if I did this, then we would be bouncing back and forth between coroutines, right? Because it would be like the move to target routine ends, and then it calls rotate right, and then rotate right ends, and it calls move to target, then move to target ends, and it calls rotate right. And they would just bounce back and forth infinitely, right? Which might be which might be okay in some circumstances if you wanted a behavior to repeat, but it's not what the desired behavior in this circumstance is. So what we need here is we need some kind of overarching structure to kind of call these coroutines, you know, in an overarching kind of sequence, right? So we're going to add, we're going to get rid of these calls to start coroutine, and we're going to add another coroutine that is kind of, you know, an overarching sequence of actions. So IEnumerator, and we'll call this sequence, and it doesn't have to accept any parameters. And the cool thing about coroutines is that you can actually tell a coroutine to not only start another coroutine, but also wait until or yield until that coroutine has finished. So if I wanted my structure to be start coroutine and then move to target 1, and then start coroutine, rotate right, and start coroutine, move to target 2. That's really the sequence of events that I want to happen, right? But if I wrote it like this, then these would all happen at the same time, right? Because I'm telling Unity, start this coroutine, then start this coroutine, then start this coroutine, then I'm done, right? So then it's going to start running these all in parallel. So I don't know about having these two that affect the transform at the same time. So let's comment the third one out. But let's just look at what happens when we run it with just these two at the same time. Oh, and we have it likes to, UD also likes to have all its coroutines have a yield statement in it. So it's kind of a weird thing. So I'm going to just yield break at the end to get rid of this error. And then I'm going to hit play. So we actually, we didn't even get the turn. So so I would have thought maybe that it would turn at the same time, but we didn't even get that. So the problem is that we're not yielding. So if we say yield return, then we're telling Unity I want to wait until that coroutine is finished. So yield return. Now that I'm yielding on these coroutines, on this start coroutine method, the start coroutine will return a coroutine, and Unity will block on that until it's completed. So it will do that with move to target 1, rotate right, and then move to target 2. So now let's look at how that looks. Move to target 1, and we're having a problem with rotate right. Okay, I see what I did. All right, so let's go back in here, and we realize that actually when we started that first coroutine, we're still starting move to target. So let's change that out for the sequence. So what we really want to start is the overarching sequence, right? And now we're moving to target 1, rotating right, and then moving to target 2. Then when we go in the editor, we actually have to assign target 2 as sphere 2. And now when we hit play, we should move to the first target, wait a second, turn to the right, move to the second target. And it's that easy. So let's go back and just try that one more time where we do not have the yield statements. So we'll add that yield break to the end again, and then we'll just call start coroutine both times. So now we're starting the coroutine, starting this other coroutine, then yielding. So now, hopefully, when we hit play, those two things, the move and the turn right, will happen in parallel. So yep, we see that as we're moving, we turn right, in this case, both at 2 seconds. So that's actually kind of cool too, but not what we're looking for. So to make sure that these things happen in sequence, we have to have that yield return, and then we'll know that we have to block on the first one, block on the second one, and then obviously we add back in the third move to target to complete our move to target, rotate right, and move to second target. And that's it. That shows just kind of like some of the power of coroutines and what we can do with them.